All right, today's lesson is on two-way tables, the general addition rule, and Venn diagrams. And we've seen two-way tables before in this class, so today we're going to learn how to look at them and answer some probability questions. So far, you've learned how to model chance behavior and find probability for mutually exclusive events. And if you'll remember from last time, that means those two events cannot happen at the same time. But today we're going to be able to answer the question, what if we want to find the probability of two events that aren't mutually exclusive, two events that can happen at the same time? Here's an example. In 2018, a survey suggested that 51% of teenagers use Facebook, 72% use Instagram, and 38% do both. Suppose we select a teenager at random. What's the probability that the teen uses Facebook or Instagram? Or how about the probability that a teen does not use Facebook and does not use Instagram? So these events can happen at the same time, so they're not mutually exclusive. So we can't use the formula that we used for mutually exclusive events. So let's kind of dissect this a little bit. When you see the word or in the English language, it can be used two different ways. These events on one, these would be considered mutually exclusive. If you're asked, do you want soup or salad? You choose one or the other. You won't say, oh, I want both. So this type of or means that you can only choose one. So these are mutually exclusive events here, and we talked about this in the last section of notes. But number two, this type of or, do you want cream or sugar in your coffee? It's perfectly acceptable to say, hey, I want both of those, cream and sugar. So those are not mutually exclusive, and this is kind of where two-way tables come in. So look at example one, and we're going to see this table throughout different notes that we come across throughout the chapter, so kind of keep this example in mind. Students in a statistics class wanted to find out how common it is for young adults to be able to roll their tongues, like make a little taco out of your tongue, or to raise one eyebrow. We'll call that evil eyebrow. They recorded data on the two variables, so this two-way table summarizes the data. So we have 200 total students, and we've got the totals of everybody who said yes, they can roll their tongue, no they can't, yes they can evil eyebrow, no they can't. So we're going to look at these scenarios and see if we can answer these from the two-way table. Suppose we choose a student from at random, and you need to know down here when it says A and B what they're talking about. So event A is you can roll your tongue, you can taco tongue, and event B is going to be evil eyebrow. Student can evil eyebrow, and event A is can taco tongue. So A says, find the probability of B and describe it in words. Well, the probability of event B happening is the probability that a student said, yes, they can evil eyebrow. So a student can evil eyebrow, and we'll just abbreviate that with EE. Well, if you look in the table, the students that said that they can evil eyebrow, that's a total of 62 students out of the 200 total students. So we would set up the probability at 62 over 200, which is going to be 0.31. When it says describe the probability in words, that just means that if you choose a student at random, there's a 31% chance that they say they can evil eyebrow. All right, let's move on to B. Find the probability of event A and B occurring. So that would be the probability that a student said, yes, they can taco tongue, and that same student can evil eyebrow. So look for the students who said they can do both. That would be the yes, yes students. That's a total of 42 students in all, so 42 out of 200. They can do both, taco tongue and evil eyebrow. So that gives us 0.21 when we divide out in the calculator. And lastly, part C, they switched one little word there from and to or, and let's see what kind of a difference that makes. So find the probability that a student can taco tongue or evil eyebrow. So we have to be really careful here. Let's look up in the table. Anybody that said that they can taco tongue, yes, yes. The 42 and the 107 are both included. Well, anyone that said that they can evil eyebrow is also included. I don't want to circle that 42 again because I've already counted those students once, but I need to also include these category over here that say yes, they can evil eyebrow even though they can't taco tongue. So these three orange numbers are going to be the numerator of the fraction. We'll add those together. So a total of 107 plus 42 plus 20 students said that they could do either of those things, taco tongue or evil eyebrow, out of, once again, the total 200. When you add all those numbers together and divide by 200, you get 0.845. And we'll just say 0.85. So this one little word, and versus or, the rest of the chapter we're going to start talking about the difference of those in two-way tables, Venn diagrams, tree diagrams. So you're going to have to be really comfortable with the difference in the and the or. Okay, you can turn the page. And what it says at the top there is what I already explained. You have to be careful not to count the 42 students twice when you're saying all the taco tongue and evil eyebrow people. So what I've done here is I've just kind of shaded in light gray and shown you where they overlap here in dark gray. Just make a note that this 42 students right here, that's going to be the events A and B happening together. They can do both things, both events, A and B. They said, yes, they can taco tongue. Yes, they can evil eyebrow. They can do both. So don't double count those. And we're going to talk about that in the formula at the bottom of the page here. It kind of takes care of that so you don't end up double counting. It says right here, we can fix this double counting problem by subtracting. So what that means is if you want to just go to the totals and you say, okay, I want to know everyone who said they can taco tongue. Well, that's 149. And I want to look at everyone who said they can evil eyebrow. That's 62. If you want to just add those two together, that's fine, but you'll have to subtract out one of the 42s because you will have double counted it in these 149 and 62 numbers. So the formula just says, not to make things more complicated, but the formula just says what we want to do if we want to find the probability of taco tongue or evil eyebrow, students who can do either or, then what we want to do is take the probability that a student can taco tongue, add it to the probability that they can evil eyebrow. That's going to be the 149 and the 62, but then we need to subtract out the probability that a student can taco tongue and evil eyebrow. So let me fix this really fast. And that's that 42 that we'll subtract out.